Let's discuss mineral resources, including the different types of ore minerals, ore deposits, and processing techniques. Since energy-related resources like coal, uranium, etc., were discussed separately, this lecture will focus on non-energy related metallic and non-metallic mineral resources, like sulfide and oxide ores. Examples of mineral resources from Arizona and elsewhere are included throughout the presentation. We will also look at a few other resources that provide essential materials used in our daily life, like bauxite, iron ore, rare earth elements, and others. This image shows one of the most important mineral resources of human history, iron ore. The first large-scale production of iron occurred almost 3,000 years ago. Iron ore combined with a small amount of carbon forms a hugely important alloy, steel, which has been instrumental in building modern human civilization. Our civilization requires mineral resources for many different uses, and these mineral resources have to be either mined or imported. Take a look at some of the important resources that have to be imported in significant amounts, at least as of 1998. Aluminum, 30% is imported, and that's useful for constructing jet aircraft, for example. Rare earth elements, 72% of these are imported, and they're critical for all sorts of electronics. Titanium, 77% imported, again important for making jet engines and aircraft, even spacecraft. Yttrium, this rare earth element, 100% of which is imported, and that's crucial for making LEDs. Alumina and bauxite, raw aluminum ore, 100% is imported, and the list goes on. So, yes, this list is somewhat dated, but the U.S. has largely grown even more dependent on these imports in recent years. Economic resources are market-defined deposits that are both discovered and undiscovered. Economic reserves are known resources that are economical to recover. Exploration may end up turning hypothetical resources into reserves. Alternatively, technological advances and various market factors may turn conditional resources into reserves. Old English for unwrought metal, an ore is rock containing abundant ore minerals and metals that can be profitably extracted. For example, iron ores typically have 30 to 60% iron. Ore minerals, or economic minerals, are those that contain high percentages of economically valuable metals. For instance, magnetite is an ore mineral that contains 72% iron. Ore deposits are accumulations of ore minerals concentrated by various geologic processes. There are two main types of ore deposits, vein and disseminated. Vein ore deposits are usually concentrated along fractures or faults, and ore minerals are present in relatively high abundances. Vein ores are typically extracted via underground mining methods. Disseminated ore deposits are spread throughout large volumes of rock, and thus have relatively low metal concentrations, like less than 1%. Disseminated ores are extracted usually using open-pit mining methods. Sulfide ores are those that combine sulfur with valuable metals like iron, lead, copper, silver, etc. Common sulfide ore minerals include shiny to dull gray galena, a lead sulfide, and a Dr. Bob favorite. Reddish cinnabar is a mercury sulfide. Pyrite is an iron sulfide with a shiny brassy luster, another Dr. Bob fave. And dark-colored sphalerite is a zinc sulfide. Oxide ores are those that most commonly have minerals that combine oxygen with copper. These ore minerals have chemical formulae that are typically more complex than those of the sulfide ore minerals. Common oxide ore minerals include the blue-green colored chrysocolla, dark blue-colored azurite, and green-colored malachite. Because of their different compositions, copper sulfide and copper oxide ores are typically processed by separate methods. In a nutshell, the sulfide and oxide ore processing is somewhat similar, except mainly that smelting is necessary for sulfide ores, whereas it isn't for oxide ores. For copper sulfide ores, the first step is crushing. The ore material is pulverized to 1/2 inch or smaller pieces in a rod mill or ball mill. basically huge drums filled with steel rods or balls. Flotation is next. The crushed material is conveyed to a flotation vat filled with an organic solution. The copper adheres to certain chemical agents and floats to the top, whereas the waste rock sinks to the bottom. At this point in the process, the copper ore is concentrated to about 30% grade. The copper is then smelted. The sulfide concentrate is sent to a flash furnace, heated and melted to separate the copper from the sulfur, iron, and other unwanted compounds. The slag, or waste material, floats to the top and is separated from the liquid copper matte, which is poured from the bottom. The copper matte is 30 to 70% pure copper. The copper matte is then sent to a converter, which separates the sulfur from the copper. The sulfur dioxide is removed and captured for use in leaching processes. The remaining copper is known as blister and is 98.5 to 99.5% pure copper. The blister copper is then sent to an anode furnace, where it is further refined and cast into anodes for use in electrolytic refining. The final stages employ electrorefining, which involves electrochemically dissolving copper from an impure copper anode, the positive electrode, in an electrolyte containing copper sulfate and sulfuric acid, with subsequent electrochemical attraction and deposition of copper ions from the electrolyte onto a stainless steel or copper cathode, the negative electrode. As the electrolysis progresses, the impure copper anode dissolves away and pure copper builds up a thicker and thicker coating on the cathode. Each anode is electrorefined until about 80 to 85% of the mass is dissolved. Insoluble impurities in the anode adhere to the anode or fall to the bottom of the refining cell, where they are removed and sent to a byproduct metal recovery plant. Mature copper-loaded cathodes typically weigh between 50 and 160 kilograms and are removed from the cells after 7 to 10 days of plating. 2 or 3 cathode plating cycles are produced from a single anode, with each finished cathode being more than 99.9% pure copper. As with the sulfide ores, the first step in processing copper oxide ores is crushing. The crushed ore is then transported to a lined leach dump, where sulfuric acid is sprayed onto the crushed ore. Alternatively, the crushed ore can be sent to a sulfuric acid leaching tank or vat. Either way, the resulting copper sulfate pregnant leach solution is then sent to the solvent extraction and electrowinning plant, or SXEW. At the SXEW plant, the copper sulfate leach solution is mixed with organic reagent solution to further concentrate the dissolved copper, and the waste sulfuric acid is recycled back onto the leach dumps. This copper sulfate solution is then sent to the electrowinning tanks to be electrolytically refined. In electrowinning, an electrical current is passed from an inert anode, typically made out of lead, through the copper sulfate solution containing the dissolved copper ions. The copper ions are then attracted to and deposit onto the cathode. The finished cathode is then more than 99.99% pure copper. Arizona is home to many different kinds of ore deposits. Let's start with porphyry copper deposits. These are low-grade, disseminated ores, typically related to granitic to dioritic porphyry stocks. Due to their disseminated nature, these deposits are usually mined by open-pit methods. In Arizona, porphyry copper deposits are mostly late Mesozoic to early Cenozoic in age and are found in the Basin Range and Transition Zone. The Morenci open-pit mine is one of the largest in the United States and in the world for that matter. In 2012, it produced a whopping 632 million pounds of copper. Other large operations in Arizona include open-pit mines at Ray, Baghdad, Safford, and other places. The Morenci Mine is an open-pit copper and molybdenum mining complex in southeastern Arizona. Morenci is the /1 copper-producing mine in the U.S., with 441,000 tons of copper extracted in 2022. The mine operates 24/7, 365, extracting about 900 metric tons per day. The ore bodies include copper oxide and sulfide ores related to a large Eocene porphyry copper system. Several cycles of leaching and enrichment of the primary sulfide ores formed the secondary sulfide enrichment blanket and copper oxide zones, with mineralization spanning an area of about 4 by 5 miles across. Chalcopyrite is the primary copper sulfide, much of which has been modified into secondary, more copper-rich sulfides like chalcocite and oxides like chrysocolla. Specific ore bodies include the Garfield, Metcalfe, Coronado, Northwest Extension, etc. The northern half of the complex includes large open pit areas like Garfield, Shannon, Metcalfe, Coronado, and Southside, and their related stockpile dumps. Mining is designed to take place on 50-foot wide benches, with haul ramps that are 120 feet wide with a steep 10% grade. As of December 2022, mine operations included over 1,700 employees and contractors, involved with drilling, blasting, loading, hauling, and auxiliary support, utilizing 13 electric rope shovels, 6 front-end loaders, and 146 267-ton capacity haul trucks, all supported by a fleet of track dozers, wheel loaders, motor graders, backhoes, and water trucks. U.S. Highway 191 separates the large open pit area from most of the processing facilities and large tailings dumps to the south. The southern half of the mine is home to 2 concentrator mills and several SX-EW facilities, as well as numerous large tailings stockpiles and tailings storage facilities. Tailings are the finely ground rock particles left after copper or other minerals have been processed and extracted from the mined ore. The mine currently has 8 large tailings storage facilities. As of 2022, Morenci's mineral reserves, both proven and probable, were estimated at around 15.7 billion pounds of recoverable copper and 286 million pounds of molybdenum. Massive sulfides are seafloor hydrothermal vent deposits that occur in 2 main varieties. Volcanogenic massive sulfides are associated with volcanic-driven submarine hydrothermal vents, which include the aptly named black smokers and even white smokers. Volcanogenic massive sulfides are found in central Arizona and typically include large amounts of copper, zinc, lead, gold, and silver. Massive sulfides are found in Proterozoic rocks of the transition zone in central Arizona and are typically mined using underground methods. Located in Jerome, the United Verde mine was a large mining operation from 1883 to 1953. Smaller but similar types of deposits are scattered throughout the mountains of central Arizona. The United Verde mine is located in the Black Hills of central Arizona. The Hohokam, and later Sonawa, may have been the first to discover silver and copper in the Jerome area between 700 and 1425 CE, followed later by the Spanish in the late 16th century. The United Verde mine operated from 1883 to 1975, producing 33 million tons of ore, averaging 4.8% copper. This included almost 3 billion pounds of copper, 53 million pounds of zinc, 1.3 million ounces of gold, and 48.3 million ounces of silver. The ore body is a volcanogenic massive sulfide deposit, originally formed around seafloor hydrothermal vents about 1.74 billion years ago. Unlike porphyry copper deposits, volcanogenic massive sulfide ore deposits are smaller, more compact, and have a higher metal percentage. The steeply dipping cylindrical ore body is approximately 800 feet in diameter and extends to a depth of 2,400 feet. Primary sulfide ore minerals include pyrite and chalcopyrite, whereas the oxide supergene minerals include cuprite, azurite, malachite, etc. Beginning in 1883, the ore body was initially mined by underground methods, but a series of underground fires and cave-ins made mining increasingly problematic. Open pit operations commenced in 1918 and continued until 1953, with small-scale operations lasting until 1975. The separate United Verde Extension ore deposit was smaller, but averaged 10.2% copper. Asbestos is actually a group of several different types of fibrous minerals. The white asbestos, chrysotile, is relatively soluble in water and is not as significantly carcinogenic as the amphibole-based chrysotolite, which is not water-soluble, and its needle-shaped fibers cause them to get lodged in lung tissue. Chrysotile, though, accounts for more than 95% of the asbestos used in most U.S. buildings, and it's so widely used because of its heat-retardant qualities. That said, exposure to all forms of asbestos carries some health risks, but the truth is, some fibers occur naturally in the air and we breathe them all the time. Regardless, from a health risk point of view, all types of asbestos are viewed as extreme health hazards. And asbestos abatement is very expensive. We're talking billions per year. Asbestos occurs locally in Proterozoic rocks in the transition zone of central Arizona, typically in areas where certain rocks have been altered by contact metamorphism from a nearby intrusion. Here, the Mezcal limestone has been metamorphosed by a diabase sill. This is in the Salt River Canyon area. The uranium oxide ore mineral, uraninite, was formerly mined from sedimentary rocks all across Arizona. It has also been discovered in breccia pipes on the Colorado Plateau, where groundwater movement serves to concentrate various minerals. None of these deposits are being currently mined. Iron ores are important sources of iron, and include minerals like hematite and magnetite. There are different types of iron ore deposits, but banded iron formation is probably the most important source. In 2022, Australia, China, Brazil, and India produced 3/4 of the world's iron ore. In the U.S., iron ore mostly has been mined from the Iron Ranges in and around Lake Superior. These small linear mountain ranges include the Mesabi, Gunflint, Gogobek, and others. Iron ore is used primarily to make steel, an iron-carbon alloy, which has countless applications, and along with concrete, has helped build modern human civilization. Let's talk about a few other common mineral resources. Bauxite is a sedimentary rock and the main ore of aluminum. It's typically loaded with aluminum hydroxides like gibbsite, baemite, and diaspore. Bauxite forms mostly by intense chemical weathering of soil and rock in tropical areas. The leached material is known as laterite. Since it forms in a layer near the surface, it is strip mined and then processed by electrolysis. Extracting aluminum from bauxite ore is much more expensive than recycling, explaining why aluminum is an economically attractive recycling resource. Aluminum is used to make lightweight metal alloys and compounds used everywhere, including beverage cans, food packaging, building materials, aircraft, and all sorts of things. Rare earth elements have gained prominence during the last several decades. This group of 15 heavy metals, also known as the lanthanides, include the light rare earths, lanthanum to gadolinium, and the heavy rare earth elements, terbium to lutetium. The elements scandium and yttrium are not true rare earth elements, but display similar characteristics. These elements are present in a variety of exotic minerals like gadolinite, xenotime, euxenite, and yttrophlorite. China currently dominates production of the rare earth elements, about 80% as of 2019. But due to their scarcity and importance to national security, this may be slowly changing as other countries have prioritized rare earth production. Rare earth elements have many uses in electronics, LEDs, lasers, batteries, magnets, metal alloys, ceramics, glass making, as chemical catalysts, and on and on and on. Limestone, of course, is a carbonate sedimentary rock. It's an abundant industrial and agricultural resource and widely used as a raw material in building stone. It's the source of lime, not only used as a soil amendment in agriculture, but also to make steel, paper, glass, etc. Limestone is also a common raw material used to make aggregate, cement, and brick. It has been used as a building stone since antiquity, used in the construction of many iconic buildings. from the Temple of Kukulkan in the Mayan city of Chichen Itza, the Great Pyramid and Sphinx in Egypt, the Lincoln Memorial and Alamo in the United States. Cal Portland's Twin Peaks Aggregate Quarry is located just northwest of Tucson. The Twin Peaks Quarry produces material for the nearby Portland Cement Plant in Rito. The cement plant has a capacity of 1.1 million tons of cement per year. Only one of the Twin Peaks remains, as the 500-foot eastern peak has been totally removed to produce more than 14 million tons of rock for cement production. The quarried bedrock here is composed of folded and faulted Paleozoic carbonate rocks, including Devonian Martin Formation dolostone, Mississippian Escabrosa limestone and Horquilla limestone, and limestone of the Penperm Naco group. The western butte is composed mostly of Proterozoic schist and granite, as well as the Cambrian Bolsa quartzite and Abrigo Formation. Limestone that is too high in silica or magnesium oxide content is crushed, sized, and sold as aggregate. Gypsum, Greek for plaster, is a calcium sulfate evaporite mineral that is usually associated with other evaporite minerals like halite and anhydrite. Gypsum occurs in different forms, including massive alabaster, fibrous satin spar, and selenite. Gypsum is an important industrial mineral, here shown being mined in Gypsum, Colorado near Vail. Gypsum is used mostly in the construction industry to make wallboard, but is also important in making cement, as a soil amendment, and has other uses. American Gypsum has operated a wallboard plant and quarry in Gypsum, Colorado since the 1980s. The two open-pit gypsum mines are the largest gypsum mines in Colorado and are located in the Middle Pennsylvanian Eagle Valley Evaporite, which contains gypsum and anhydrite interbedded with siltstone and minor dolostone. The quarries and associated wallboard plant are located along I-70, and as of 2020, produce about 600 million square feet of drywall per year. The gypsum is trenched and sorted, with the usable material trucked to the nearby plant for processing. It's estimated that gypsum reserves here are enough to last at least another 60 years. Note, drywall is also known as wallboard, plasterboard, gypsum board, and sheetrock. And there are many types of drywall, with all varieties containing gypsum. Well, that's all for now. Till next time.